So what is a differential equation? We got a definition here. It's an equation with a function and one or more of its derivatives, which could be like, its second derivative, third derivative, all these mixed around and stuff. So this is an example, y plus, this could be y prime, dy dx, same thing, equals 5x. That's a differential equation. What you see here is dy dx. Immediately when you see dy dx, you actually have a differential equation. But notice we're also mixing x and y. Typically, in our past, we would find the derivative, we'd get like y prime equals 2x plus 3, and we wouldn't see the function y in here. This is a little bit more like that implicit differentiation feel to it, and so you'll see y, you'll see dy dx, or y prime as you'll see here, and that's a differential equation. So basically it's mixing up the function itself with its derivative, maybe its second derivative, its third derivative, and so on. We're only going to be dealing with first order differential equations where we only have to deal with the first derivative though. But sometimes you might see some like y double prime plus 2y minus 3y prime equals 5x. For example, something like that. So, verifying solutions. So the solution to a differential equation is going to be the original function y equals something. Right, so that's going to be our solution. So we're going to verify solutions by substituting this into our differential equation. So up here what you see is our differential equation. That's y prime. Y prime could get mixed in. Doesn't look like any of these are doing that. It has y prime just on its own. So let's talk about how we'll substitute this and verify this solution, if it's a solution. So let's start with the y prime. Y prime is going to be the derivative of this, which will be negative 2/3. Derivative of x is 1, then derivative of 1 over 9 is 0. So that's y prime. That's going to go ahead and go in for that. And let me just copy that formula, actually. Going to get some color coordination going on. So what we have is we have y prime equals negative 2 over 3x plus, oh, no, I was copying this here. So y prime equals 2x. There we go. There's our differential equation. And that's why I'm copying this, so we can distinguish what's going on here. So we have different things going on. That's why I wanted to use the colors here. So we have our differential equation. That's what I copied here. We have y given. That's in green. And then I found y prime. You can see that's in blue. So we're going to substitute this stuff in. So n for y prime is going to go negative 2/3. And we're going to see what happens if we plug everything else in here. So we have 2x. And then we know y is this here. So I'm going to plug that in for y. So plus 3 times y is negative 2/3 x. Plus 1 over 9. And then minus 1. So let's distribute this 3, see what happens. We'll probably get rid of the colored coordination now. So 3 times 2/3 is going to be 2. And then 3 over 9 is 1/3. Minus 1. And we'll have 2x minus 2x goes away. And then 1/3 minus 1 is 1/3 minus 3/3, right? If we get that common denominator, which is negative 2/3. So verifying this solution. I would say those are equivalent. So that works. So that is a solution. I'll put a big check mark just so we know, yes, that is a solution. Something a little more complicated, maybe these rational functions going on. Everything else, just substitute. It's the same idea for everything else. So let's take a look at this one. This will be our last example. So let me copy down our function. So y equals 2 over 9 plus x squared. So then how do we find its derivative? We could do the quotient rule. I'm just going to rewrite it though. So I'm going to rewrite it as 2 times 9 plus x squared to the negative 1. So y prime will equal negative 2 times 9 plus x squared to the negative 2 times 2x. And so negative 2 times 2 is going to be negative 4x. And then on the bottom we'll have our 9 plus x squared squared. So it didn't take quotient rule. It will get you the same thing if you use the quotient rule though. So what is our function? Our function, or our differential equation, I mean, is y prime equals x times y squared. So let's see what happens. So really this was all the work over here. We might get something similar. So y is 2 over 9 plus x squared squared. I think where we're going to have the issue is the negative, because if we square everything here on the right side, two squared is 4 over 9 plus x squared squared. So that's going to be 4x over 9 plus x squared squared. And so it looks like what's going to be our downfall here is going to be that negative. So this one is not going to be a solution. They got to be equal, and they ended up not equal. Not quite there.